Hi, my name is Pedro Silva, and along with my coworkers, Bhawna and Shloka, I'll be presenting some of the work we've done at Pinterest on practical end-to-end diversification in search and recommender systems. And this is the agenda we have for today. And I want to start by sharing some feedback we got from a pinner a few years ago. She told us that to see people of color in our app, she needed to physically type the word black, and that looking at our app told her that people who look like her were not the norm. This is unacceptable in any situation, but even more at Pinterest because our vision is to bring everyone the inspiration to create a life they love. And to truly be a place where everyone can find the most inspiring and relevant content for them, Pinterest is committed to content diversity and to developing an inclusive experience on the platform. That was when we identified a need for multi-stage diversification. And this is a typical search and recommendation system where you have billions of items and you retrieve a few thousand of those into candidate retrieval, and then you trim that list a little bit down into ranking, and then finally it's shown to the user. So for our work, we intervene in two parts of that system, on the ranking stage and on the retrieval stage. When you consider doing diversification in recommendations, there are a few things to be taken into consideration. The first one of them is, what is the diversity dimension you want to diversify with respect to? Is it demographics, geographics? So is it gender, country, language? Is it domain specific, like skin tone, which is the one we're going to be covering here? Is it business specific, such as merchant size and location? Is it implicit dimension, such as in the embedding space? Do you need multi-stage diversification, meaning do you need to intervene in multiple parts of that system? And also, what is your triggering logic? Meaning, when and for which queries and for which surfaces do you activate diversification? And how does diversification plays with personalization? Sometimes you want more of one or the other. Lastly, you need to understand how you're going to measure the impact. There are several ways to do that, like, for example, the normalized entropy of the distribution with respect to the diversity dimension. We chose to do diversity at K for a certain rank R, which is basically defined as a fraction of queries where all groups under our diversity dimension are represented in the top K results.
Hi, I'm Juneja, and I'll be talking about diversification approaches for ranking. We initially launched greedy round-robin algorithm with a fixed relevance threshold to perform diversification. The way it works is that we bucket the pins based on skin tone signal while keeping the original ranking order and then iterate over them one by one to pick the pin from each of the bucket for the final set. It's a simple method and it worked very well for beauty and fashion queries. It's able to prioritize diversity among the pins. But at the same time, having a fixed relevance score threshold, it's not scalable if you switch from one model to the other. If we need to add more signal, it's not able to generalize well on the same. Lastly, it's not able to balance the diversity utility trade-off where we want to maintain diversity as well as keep the relevance on par. Hence, we move towards DPP. DPP stands for Determinable Point Process, a machine learnable probabilistic model, which is widely used for repulsion modeling. It can be parameterized by a positive semi-definite kernel matrix L, where the diagonal entry represents the quality of the item. In our case, we use the final score of the pin, which is a function of different utilities. The off-diagonal entry represents the similarity between the items. Here we use the skin tone signal for the same. So solving DPP problem is basically to find a subset A or an ordering of pins that maximizes the determinant of the matrix. Hence, it's end up promoting pins of higher quality and demote the ones that are similar to each other. For running DPP, we have the following parameters. We have a kernel matrix L of length k by k, where k is the current batch size. And we also have a repulsion window size denoted by W, where the logic tries to maintain diversity within that frame. For each batch, we perform the following steps. We first initialize the set with the first pin in the ranking order. At each step, we greedily select the ith pin and add it to the existing set so that the determinant of the matrix is maximized. This can be represented as shown in the equation. We keep doing this until we reach the defined batch size, and this re-ranking for batch can also be parallelized in order to save time. Here we have an illustrative example of round-robin and DPP applied to a utility ranked list. Each block is an item in the list, and the color denotes the skin tone range of the item image. On the left side, we see the ranked list obtained after applying round-robin is reordered so that the distribution of skin tones is more uniform in the top positions, whereas on the right side, the ranked list is obtained after DPP, which allows for optimizing a list-wise objective to trade off utility and diversity of the initial ranked set.
While these approaches certainly helped us achieve our goals, we identified a further need for diversification at the retrieval layer. And the reason for that is because no matter how great your methods at diversifying the ranking stage are, you are still limited by the diversity of the items you get at retrieval. So in order to do that, we successfully tried three different approaches. The first one of them is overfetch and re-rank. So for overfetch and re-rank, firstly, you overfetch. So let's say you have a system where you want to usually fetch k items. Now you're going to fetch k prime items where that k prime is greater than k. And then you rank them based on the diversification dimension of interest. So you can use round robin for that, for example, and then you trim that list back into k items, and that's what you return downstream into the ranking layer. Next, we use bucketized approximate nearest neighbor. So a lot of these ranking systems, they use an embedding space where you retrieve items, and this is a very typical architecture where you have the root, and that request is further streamed into the leaves and the segments. The difference here is that you modify the aggregation step to account for diverse items. So instead of just returning all the items aggregated, you bucketize them into the dimension of interest like we have here for skin tone, and that's passed into the leaves and further into the root. You can again use round robin to, if you want to return a single list, or you can return the buckets themselves and let your ranking system handle on how to combine them. Lastly, we use the strong OR for our search system. So in search, text queries are usually converted into what we call structured queries, which allows some retrieval systems basically to use logical operators. So for example, on this example I have over here, you have term 1 or term 2, right? And you're trying to retrieve, if you're trying to retrieve only 5 items, a regular OR would return items 1 through 5. And this is basically the order where the items are found. But if you have a strong OR condition where you're saying, well, I want to have at least 3 items for term 1, as soon as you reach that number 3 over there, your system is going to be like, I only have 2 more spots, so I need to keep looking for the items for term 1, right? So in that case, it would return 1, 2, 3, 6, and 9 instead. On the case of diversity, that condition greater than or equals to 3, it's actually going to be your diversity condition. So that gets enforced downstream into the search space.
Hi everyone, I'm Shloka, and in this section I'll be talking about some practical considerations we kept in mind while productionizing these approaches. First, to diversify at retrieval, we need to index the diversity dimension, in this case skin tone, in both embedding-based and token-based indices. Second is impact to latency and scaling. For round robin, we found that it had minimal impact on latency due to its linear time complexity. For DPP, we reduced impact on latency through various techniques, such as tuning the batch size through offline replay or A/B experiments. Finally, we collected qualitative feedback from a diverse set of internal participants for every iteration, in addition to relevance evaluations through professional data labeling. In this section, I'll talk about the results of deploying these approaches. We deployed skin tone diversification for 3 surfaces on Pinterest: search, where a user can enter a text query and see pins that are relevant to their intent; related products, where users can see product pins that are similar to the pin they've selected; and lastly, new user home feed, which is the initial home feed they see when they first sign up on Pinterest. All results in this section are from A/B experiments run for at least 3 weeks in US and international markets. We measure impact to diversity at K and user engagement metrics. This table shows impact to skin tone diversity at K for each of the 3 surfaces using different diversification approaches. A single asterisk indicates positive impact to engagement, and a double asterisk indicates neutral impact. For all 3 surfaces, we start with round robin for ranking diversification, followed by DPP. The retrieval diversification approach varies per surface. For search, we use strong OR. For related products, bucketize AN and retrieval, and for new user home feed, overfetch and re-rank. And this is an example of diversification on related products. On the left side, we have a query pin, and on the right, we see the results before and after diversification. Here's another example on search. This is for the query pink nails matte before diversification, using round robin diversification and using DPP diversification. Some ethical considerations we kept in mind while doing this work. First, while we use skin tone ranges to surface diverse content to users, we never use them as inputs to train ML ranking models. It's also important to note that skin tone ranges are pin features, not user features. We never attempt to predict our users' personal information, such as their ethnicity. To conclude, we deployed multi-stage diversification at ranking and retrieval, ensured that it's possible to create inclusive product experience with positive impact to engagement. Our approach is scalable to multiple dimensions and supports intersectionality. Some future work could include advanced and scalable triggering mechanisms for skin tone diversification, as well as analyzing impact to serving bias through serving more diverse content. I would like to conclude by sharing recent feedback from pinners. Thank you, and I would also like to thank all our collaborators at Pinterest, without whom this work would not have been possible.